Welcome back to this new video. And in this video we are going to move to the second example, and the example is simplifying the first derivative of x cubed, that is f of x. And to find it, we'll use the definition and the formula we derived last time. We derived that the derivative dy on dx, which is equal to f prime of x, is equal to f is equal to limit as h goes to 0 of f of x plus h minus f of x, all that on h. So we are going to find the derivative of this using that, and this is what mathematician calls derivative by first principle. So if they ask you to find the derivative of something in the first principle, indeed this is what they are trying to ask you. If you don't know how to derive this formula, you can just watch the previous video that you'll find a link in the description section of this video to really know how to derive the formula. If you master the formula, then you won't have any problem with this type of problems. So we are now going to get to our f prime of x will now be equals to limit as h goes to 0, limit as h goes to 0, x plus h ordered cube, that is our f of x. Now we are cubing it. In the other video we squared it, right? We found for x squared in the other video, so now we are having x plus h ordered cube minus x cube all on h. And the way I'm going to do it is that I'm going to first, let me just write everything here, limit as h goes to 0. I will expand this x plus h ordered cube. This one is x plus h 3 times, this is the meaning, x plus h into x plus h minus x cubed, the other one that is left, all that on h. And x plus h 3 times, we did for x plus h multiplied by x plus h in the last video, and we got x squared plus 2xh plus h squared. But now we are multiplying by another x plus h. That is, I just multiply this x squared, x and so on. We just did like that, minus x cubed, all that we are dividing it by h, and our limit as h goes to 0. Now this one up there, this one here, I'm going now to take each term like this, I multiply by this and so on. So if we begin by taking the x squared, we multiply by that, we get x cubed equals to 0. We get x cubed, and we take x squared, we multiply by h, we get x squared h. We take 2x h, we multiply by x, we get 2x squared h. And we take 2x h, we multiply by h, we get 2 plus 2x h squared. And we take now h squared, multiply by that, we get plus h squared x. And we take now h squared, multiply by h, we get h cubed. And we have our minus h cubed, which is left. All that is being divided by h. And now let us try to group like terms. First thing is that you see that this s cubed minus this s cubed minus this s cubed cancels, and we are just left with this. And here we are having x squared, and that is that, and we are having x squared there. So this one we are having x squared h plus 2x squared h will give us 3x squared h. So we get 3x squared h plus 2x h squared plus h squared x. Will now be having 3h squared x. This one and this one also, we combine it. Then we have our plus h cubed, and all of these we are dividing it by h, and indeed we are having a limit as h goes to 0 of all of these. And what I would neatly do here, we'll still factor out h, because if we substitute 0 here, we'll be like dividing by 0. That is what we call the indeterminate form. And we will now get h. If I remove h in this case, we just left with 3x squared, plus if I remove h here, we just left with 3hx, plus if I remove h here, we just get h squared. All that we are dividing it by h, don't forget, and we are still applying limit as h goes to 0. And if you do that neatly, you just see that this h cancels with this h, and we are now going to have limit. We are now going to have limit as h goes to 0 of 3x squared plus 3hx plus h squared. And now we can now substitute the 0 inside, and we get 3x squared plus 3 into 0, all that x plus 0 squared. and this simply simplifies to 3x squared. So we have found that f prime of x to be equals to 3x squared, where our x, so the x, so if you are differentiating x cubed, you get 3x squared. And remember, in our last video we differentiated x squared and got 2x. Okay, now I can just say 2x to the power 1. What this is trying to tell us is that each time you are differentiating, it's just like you are taking the power that you had. Here we had cube, and this is the 3 here. Here we have squared, and this is the 2 here. And here we are having here we are having 2, and here we are having 1. In general, if you are differentiating x to the n, you get nx. Okay, and now there will be a power here which is n minus 1. So this is the formula that we have come into conclusion, that the derivative of x to the n is indeed equals to n x to the n minus 1. So this is a very good formula that you have to put in your notebooks or in your mind, that the derivative of x to the n is n x to the n minus 1, and you can apply it to all cases. So let us say if you are having x to the fourth, the derivative with respect to x, that is our y, of x to the fourth, will now get what? We now simply get 4. We bring down the power, 4, then we write our x, then we write 4 minus 1. So this will be 4x to the power 3, and so on. So if you are having x to the power 5, it will be 5x to the power 5 minus 1, which will be 5x to the power 4, and so on. So this is the general formula that we will be using. We will no more be using the first principle, because the first principle is applied always, it works. But what if you are having f of x to the 100? Are you going to write this to the 100 and expand it? No. So you just use the general formula that we have just derived. So thanks very much for watching the video. Make sure you like the video, you subscribe to the YouTube channel, and share the video to your friends. And let us continue with the next video on differentiation and some techniques to find derivatives of other functions. Thank you very much for liking and subscribing to the YouTube channel. And